Hello everyone, we're on section 12.7 now, similar solids, and we're looking at different solids now, different shapes are similar if they are the same type of solid. So that means either both rectangular prisms like we're looking at here, cones, spheres, if they're both the same type and have equal ratios of corresponding linear measures. So the scale factors are the same of the linear measures, like height or the radii between the two. If those are the same in equal ratios, corresponding ratios, then they're similar. And so again, we're going to be talking about scale factor between these similar solids, which is the common ratio of one solid to another similar one. And just for your notes, any two cubes must be similar, as well as spheres. Okay, example, given the right rectangular prism, here, this one, that is a length of 4, width of 2, and a height of 2, we want to look and see, are either one of the following two prisms, A or B, are they similar to that one? And so the way we check to see whether they are similar or not is to compare the ratios of the corresponding lengths, linear measures. So let's compare lengths. So the length of A is 8, and the length of the given, we'll just give this a G for given, is 4. And that one reduces to 2 over 1. Let's compare the width. The width of A is 4, and the width of the given is 2. And that's 2 also. So now we want to do the height. The height here is 2, and the height of the given one is also 2. Well, that height comes to 1. And so these are not going to be similar because they're not all the same. These two are the same, but this one isn't. So they are not similar. Okay? Okay, let's look at B. And I'm going to use blue. And B, let's look at, it's the length ratio first. The length of B, 6, over the length of the given, which is 4. And that's going to reduce to 3/2. The width is 3 on B and 2 on the given, and that is the same ratio, 3 to 2, 3 over 2. And let's do the height. Height of the B figure is 3, and the height of G, the given figure, is 2. So in this one, they're all 3 over 2, and so they are similar. Okay, and they are with a scale factor, and we're going to abbreviate that scale factor SF of 3/2, 3 over 2. Okay, so since the ratio of the corresponding linear measures, linear meaning just one unit, just it could be feet, 6 feet. Okay, that's a linear unit. The width is in feet. So since they are in the same ratio, the linear measures, they are similar. Okay, let's look at the example here. Sorry about the drawing. Couldn't figure out how to make cones in the program I'm using. So are the two cones similar to each other? So we look at the linear units of corresponding parts on a cone, and that would be the radius for each and the heights. So those are the two measures that we're going to look at to compare and see if these two things are similar. And so the ratio of, let's say, height of, well, I'll make it the smaller one, over the height of the larger one. The height of the smaller one is 10, and the height or altitude of the bigger one is 15. And so 10 over 15 is going to reduce to 2 over 3. Now let's look at the radius. And so the radius of the smaller unit over the radius of the larger unit. The radius of the smaller is 5, and the radius of the larger one is 10. and that is 1/2. And so these are not similar. The units, the ratio of linear measures here, the height and of the radius, the linear are not the same. And so these are not similar. Okay, so here's the theorem that we've got. The theorem says, the similar solids theorem, that if two similar solids have a scale factor of A to B, then their corresponding areas, so the ratio of their areas is going to be A squared over B squared, because remember we talked about area being a squared unit. And so the ratio of the areas would be your scale factor squared. And then the corresponding volumes will have a ratio of A cubed to B cubed, because volume is a cubed unit. So let's look at this example. The cans shown are similar, and they have a scale factor of 87 to 100. So we're going to find the surface area and the volume of the larger can. And I labeled them can number 1 and can number 2. We've got the surface area. Let's do that one first. We've got the surface area of the smaller can. So let's first take a look at what their scale factor is. The scale factor is 87 to 100. That's the scale factor. So that's what we have to start working with. Now let's look at the area ratio. The area ratio between these two figures, the ratio of their two areas is going to equal the area ratio that we're going to get by squaring the scale factor. 87 squared over 100 squared. Now that's the area ratio. And so then we set the area ratio equal to the actual surface areas. And so the first surface area of the smaller figure, and remember we have smaller right now over larger, 87 over 100. So the smaller figure over the larger figure. So the surface area of the smaller one is 51.84. And over the surface area that we don't know, there it is. And so we would cross multiply. And so I'm going to bring that over here. So we're going to do 87 squared times the S equals 100 squared times 51.84. And so we're going to plug this 100 squared times 51.84 into the calculator. But then remember, to get S by itself, we're going to have to divide by the 87 squared. So we can go ahead and solve that. S equals 100 squared times 51.84. Hit enter, and then I'm going to divide by 87 squared, and I'm going to get 68.49. And then inches squared. Because remember, this is in inches, and if you look up here, area is a squared unit, so we are in inches squared. So that would be the surface area of the larger can. Now, we're going to look at doing the same thing here for volume, except that, there we go. So now I've got to look at the volume ratio. So the volume ratio, I take that scale factor again. So we're going to be using the scale factors of 87, but this time it's going to be cubed because volume is a cubed unit, 100 cubed. So the volume ratio is here, and we set that equal to the actual ratio of volumes. Smaller on top, 28.27, over the one we don't know. Cross multiply, 87 cubed, V times V equals 100 cubed times 28.27. And when you cross multiply, I'm going to write that volume here. Remember that then you're going to divide both sides by the 87.3. And I did not leave enough room to write it. So we're going to cross multiply, which we did. Then I'm going to put 100 cubed times 28.27, hit enter, and then I'm going to divide by the 87 cubed and get 42 42.93. And this is inches cubed. So remember to put your unit of measure on these. 42.93 inches cubed would be the volume. Okay, one more example. The pyramids that we are given here are similar. We're given that they are similar figures. Pyramid P has a volume of 1,000 inches cubed. Pyramid Q has a volume, excuse me, of 216 inches cubed. Okay? Now, it says find the scale factor of Pyramid P to Pyramid Q. So we have to find the scale factor between the two. To do that, remember that the volume ratio is cubed. So this is cubed already. So let's write the volume ratio of P to Q. We've got 1,000 over 216. That is already cubed. First thing you want to do, though, when you write a fraction, so when you get these ratios, is reduce it to lowest form. Okay, remember what I said last time, that when you want to reduce a fraction to lowest form, you do 1,000 divided by 216 in your calculator, hit math, enter, enter, and we're going to get 125 over 27. So that is my volume ratio in lowest form, 127 to 120, or 125 to over 27. This is my, remember that A cubed over B cubed. So let's talk about scale factor. Now my scale factor, if you remember, is A over B, the linear units, not cubed, not squared, linear. So single, A to the first power, B to the first power, single units. All right, so scale factor is A over B. That's what I have to find. So what we basically have to do, I like one of my students formerly said that we have to uncube these numbers. So really what we're doing is taking the cube root. And if you look at your math button, so if you hit math and you scroll down to number 4, it has a little 3 in front of the radical. That is your cube root. So if you press that, number 4, it's going to give you that little cube root. Put in the number you're taking the cube root of, 125, and hit enter, and you're going to get 5. So the scale factor here is that the cube root of 125 is 5, or think to yourself, what number cubed multiplied by itself 3 times gives me 125, and that's 5. Let's think about 27. We have to think about one number that's being multiplied by itself 3 times to give me 27, and so that is 3. The scale factor between these two is 5/3. Now, if they had given me area of one of these figures, then I would have to square the scale factor to find the area ratio. So see how we're going to be going back and forth. Know that we can't go directly from a volume ratio to an area ratio. You cannot just set up a ratio between those two. One's a squared unit, one's a cubed unit. We can't do that. So we would have to take that ratio all the way back to scale factor first and then square it again to get the ratio of areas. So keep that in mind because we're going to have to be doing that. And I will see you on the next video.